Welcome to Get Your FRQ On. This question is from 2024. It's question 3, and it is not calculator active. In the question stem, we have a differential equation, dH dt, that represents the depth of seawater at a specific location. In part A of the question, we are asked to sketch the solution curve to the differential equation through the point 0,4. Notice that the point 0,4 has already been provided to you on the slope field. So really it's just a matter of following the slope field and not doing anything obviously wrong. So just draw something that looks kind of like this and you should be okay. In part B of the question, we are given that h is greater than 1 on the open interval from 0 to 5. We are asked to find critical points of h on this interval and determine if those critical points are a minimum, maximum, or neither. So critical points of h will occur when dH dt is equal to 0. So if we take our equation for dH dt, set it equal to 0, that will imply that either h is equal to 1 or cosine of t over 2 is equal to 0. However, we were given that h is always greater than 1 on this interval, so h will never equal 1, so we do not need to consider the possibility that h is equal to 1. This leaves us with only the possibility that cosine of t over 2 is equal to 0, and if that's true, that implies that t equals pi. All right, so h has a critical point at t equals pi. All right, since h has a critical point at t equals pi, we still need to determine whether this is a minimum, a maximum, or a neither. So if we find the second derivative of h with respect to t, we should be able to analyze the concavity of h and then make a determination about whether or not there's a maximum, minimum, or neither at t equals pi. So if we figure out d squared h dt squared, right, doing the work, 1/2 of dH dt cosine t over 2 minus 1/4 of h minus 1 times sine of t over 2. Start simplifying. dH dt, remember that was 1/2 of h minus 1 times cosine of t over 2. So if we substitute that in, we now have 1/4 of h minus 1 times cosine squared of t over 2 minus 1/4 of h minus 1 times sine of t over 2. Notice the common factor here of 1/4 h minus 1, so I'm going to factor that out. All right, now cosine squared of t over 2 minus sine of t over 2 is the factor we need to concern ourselves with. Since h is greater than 1 on this interval, we know that the 1/4 of h minus 1 will always be positive. So if we evaluate the second derivative specifically at t equals pi, cosine squared of pi halves is 0, minus sine of pi halves, which is 1. 0 minus 1 is negative 1. We now have 1/4 of h minus 1 times negative 1, which must be negative since h minus 1 is greater than 1 on this interval. We know that's positive, and a positive times a negative is negative. So the second derivative of h is negative at t equals pi, which means h is concave down, which means that at t equals pi, h of t has a maximum. In part C of this question, we are asked to use separation of variables to find a solution for h that goes through the point 0, 4. All right, so if we take our equation for dH dt, all right, start separating the variables. dH over h minus 1 is 1/2 cosine t over 2 dt. Integrate both sides. The integral of dH over h minus 1 is the integral of 1/2 cosine t over 2 dt. Start integrating, we get the natural log of the absolute value of h minus 1 is sine of t over 2 plus c. Exponentiating both sides, we get the absolute value of h minus 1 equals plus or minus some constant times e to the sine of t over 2. Now that information that h is greater than 1 on the interval from 0 to 4 comes in handy. since h is greater than 1, we know that the absolute value of h minus 1 will still just be h minus 1, so we don't need the absolute value symbols. And we get h minus 1 is some constant times e to the sine of t over 2, which means h is 1 plus k times e to the sine t over 2. Now we can use our initial condition. Set h equal to 4, t equal to 0. We get 4 equals 1 plus k times e to the sine t over 2, which means 3 is equal to k times e to the 0, which means k is equal to 3. And ultimately, we get a solution h equals 1 plus 3e to the sine t over 2. Don't forget to like and subscribe if you appreciate the videos we make here at Get Your FRQ On.